This lesson describes the operation of typical 70s-era inertial navigation systems such as the Litton LTN51 and the Delco carousel. Before any INS operation can take place, both AC and DC power supplies must be available from the aircraft bus bars. These may be initially provided from an external power unit or the APU. Eventually, the power must be provided by internal aircraft power from the alternators or generators. The INS Mode Selector Unit, or MSU, is then switched from off to standby. This allows aircraft power through to the INS and initiates the IN's own power supplies. With standby selected, it is now possible to enter an initial present position. Switch the MSU rotary switch to POS, which stands for Present Position. Note that the keypad has some multifunction keys. For instance, 2 is also N, which stands for North. 4 is also West. 6 is also East. And 8 is also South. In present position mode, the keypad will accept only N or S as the first key press. It will not misinterpret them as 2 or 8. Enter the present position using the format N or S, followed by degrees, degrees, minutes, minutes, decimal minutes. At the first key press, that is N or S, the insert blue light comes on. It is both a button and a light. Now put in the latitude. Check the entry in the light emitting diode or LED display. If the entry is incorrect, use the Clear button to correct it, one space at a time. Now enter the longitude. This will be E or W, followed by degrees, 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 minutes, minutes, decimal minutes. Again, the system will accept only E or W for the next press. It will not misinterpret them as a 6 or a 4. There are only 5 digits for the latitude because the maximum number of digits for the degrees is 2, as you can't have more than 90 degrees north or south. However, there are 6 digits for the longitude because 3 digits are needed for the degrees, as there are up to 180 degrees of longitude. Once satisfied that the present position that you have entered is correct, press the Insert button. The Insert light goes out and the present position is entered into the computer. Alignment can now begin. Select the MSU rotary switch to align. Alignment may take up to 17 minutes and the countdown starts when the switch is set to align. Alignment is then under automatic control by the computer and no further aircrew actions are required until it is complete. On completion, the MSU green Ready Nav light will come on. After this, the crew will switch the rotary selector to Nav when ready to move. Alignment can also take place with Nav selected on the MSU rotary switch. If, after inserting present position in standby, a double click through Align to Nav is made, the internal computer will put the system into align mode despite the switch position until alignment is complete. At this point, the Ready Nav light will come on and the system will automatically go into Nav mode without any further selection. Clearly, it is advisable to select Align or Nav as early as possible in the checklist sequence, as there will be 17 minutes to wait before the aircraft can be moved, and it would be better to do the bulk of the pre-start checks after selecting Align in order to make productive use of the time. It is possible to check on how much time remains to complete the alignment, although there is not much point. It will not make the alignment any faster. However, the facility exists during alignment by use of the desired track system status position on the CDU rotary switch. There are 2 windows on the CDU LED display, left and right. In POS and waypoint, the left is for latitude and the right for longitude. In any other mode, the left is for the first named and the right for the second. In desired track system status, the desired track will not be applicable at this stage because no waypoints will have been selected, but during alignment, STS gives an indication of time remaining to complete the alignment. The detail of the display varies from manufacturer to manufacturer. In some systems, the display is minutes to go to completion of alignment, and on others there is a code number that gives an indication of which substage of alignment is currently taking place. In the Lytton system, for instance, 40 indicates fine align. This gives an approximate estimate of time to go. However, the most useful way to spend the time waiting for alignment to complete would be to load the waypoints. This can be done before selecting nav. Up to 9 waypoints can be stored at any one time. To select which store to load, there is a small thumb wheel. Rotate the wheel to the appropriate store. Then select the rotary display switch to WPT. The method of entering a waypoint is exactly as for entering a present position. Repeat this procedure for the first 9 waypoints of the route. If there are more than 9 on the route, subsequent waypoints can be loaded in flight once the early ones have been overflown and are no longer required. Once alignment is complete, select Nav. The alignment is now protected and the aircraft can be taxied or pushed back. If the system operates normally, it will now remain in nav until final shutdown. Although the INS will provide heading, track, ground speed and drift for general navigation, one of its most useful facilities is waypoint steering. A flight plan route of initially up to 9 waypoints can be entered, and a steer signal to follow the route along its various legs can be generated and displayed on the flight director system, either as a guide or to the autopilot to automatically steer the aircraft along the route. The INS is not always connected to the autopilot, and therefore it is possible for the aircraft to be positioned off its desired INS track. To enter a waypoint steer, press the Track Change button. The blue lights in the Track Change button and also the Insert button light up. Then enter the pair of waypoints to steer between in the order from to. In other words, to steer from waypoint 1 to waypoint 2, enter 1, 2. The numbers 1, 2 appear in the LEDs above the Track Change button. Press the Insert button to enter them into the computer. The Track Change and Insert lights go out. If the Auto Manual Remote Selector is switched to Auto, then, on reaching waypoint 2, an automatic changeover takes place. The LED display changes to 2, 3, and the aircraft is steered along the next leg. It is normal when route flying to use auto mode and automatically change over from leg to leg. Almost all routes will require more than 9 waypoints. This is no problem. Suppose waypoints 1 and 2 have been overflown and the aircraft is now on the leg between waypoint 3 and waypoint 4. Waypoints 1 and 2 are no longer required. Waypoint 10 can be loaded into store number 1 and waypoint 11 can be loaded into store number 2. As the aircraft completes the leg from waypoint 8 to waypoint 9, the automatic changeover will go to 9, 1 for the next leg. So, provided that the waypoint stores are updated in flight by the crew when the previous waypoints are no longer needed, it is possible to run through the 9 waypoint stores as many times as is required. The alert light warns the crew of the approach of a waypoint. Otherwise, the aircraft could roll to 25 degrees of bank at waypoint changeover onto the new heading without the crew expecting it, which could cause concern on the flight deck. The exact indications vary with the model of INS and the mode selected, but In most systems, the alert light gives a steady illumination at about 2 minutes to go, changing to a flashing light at 30 seconds to go. The steer signal tracks the aircraft down the centre line of the route between the two waypoints in use. If the aircraft is out to the side of the route for any reason, it will be S-turned back onto the centre line at quite a sharp angle. It is not steered directly to the next waypoint. However, there is a facility for steering directly from present position to a waypoint. This is called Waypoint 0. It is not possible to preload a Waypoint 0 because there is no 0 selection on the thumb wheel. But if the operator selects Track Change 0 to Insert, the present position at the moment of pressing Insert is inserted as Waypoint 0, and the aircraft is steered from that position directly to Waypoint 2. The various displays available on the control and display unit are selected by use of the rotary selector switch. With the rotary selector on track and ground speed, the left display shows the true track to the nearest 1/10 of a degree, and the ground speed to the nearest knot. Selection of heading and drift angle gives a left display of true heading to the nearest 1/10 of a degree, and a right display of drift expressed as degrees left or right, also to the nearest 1/10 of a degree. For cross-track displacement and track angle error to be operative, a steer between two waypoints must be selected. The left display shows the cross-track displacement from the centre line between the two waypoints. It would look like this. The diagram shows a desired track of 060 degrees. The aircraft is positioned 12 nautical miles to the right of the desired centre line. The right shows the difference between the aircraft track at the present time and the desired track between the waypoints in use. This would look like this. The aircraft's actual track at this time, which is the instantaneous combination of heading and drift, is 20 degrees left of the desired track between the selected waypoints. With the rotary switch at POS, the present position latitude is shown in the left window, and the longitude in the right window. Both are shown to an accuracy of the nearest 1/10 of a minute of latitude or longitude. Selection of waypoint displays the latitude and longitude of whichever waypoint has been selected in the waypoint selector thumb wheel to the nearest 1/10 of a minute of latitude or longitude. With the rotary selector in distance to go and time to go, the left-hand display shows the distance to go to the nearest nautical mile, and the time to go to the nearest 1/10 of a minute from present position to the two waypoints along the route, between the two waypoints selected in the From To LED display. The time to go is calculated from the present ground speed, and the system is responsive to changes in ground speed. If the thrust is reduced as the speed trickles off, the operator can see the time to go increasing as he watches. With wind selected, the left window shows the wind direction to the nearest degree, and the right one shows the wind speed to the nearest knot. In order to calculate wind velocity, 4 inputs are required. These are heading, drift or track, ground speed, and true airspeed. The INS generates the first 3 itself. It is necessary to have an input of TAS from another source in order to calculate wind velocity. On its own, INS has no facility for calculating TAS. However, any aircraft which has an avionics suite sophisticated enough to include an INS will also include an air data computer which will provide the TAS to the IN. DSR Track STS stands for Desired Track and System Status. The desired track is the initial great circle true track between the waypoints selected in the From To LED display, and is shown to the nearest 1/10 of a degree. We mentioned earlier that system status can give an indication of time remaining to align. However, once nav has been selected on the MSU rotary switch, STS is used to indicate serviceability and for fault diagnosis. If the INS is serviceable, the code, usually 0000, appears in the right-hand LED. Its main use, however, is for fault diagnosis in conjunction with the red WARN light. The INS carries out a continuous process of self-monitoring as part of its operating routine. If any malfunction is detected, the WARN light illuminates. The WARN light simply indicates that there is a failure. It does not tell the operator what it is. To diagnose the fault, select Desired Track, System Status. In the right-hand window, a 4-digit status code will be indicated. This 4-digit group is used in conjunction with the pilot's operating handbook. In the Malfunctions checklist, there is a table consisting of 3 columns. The first gives the numerical code, the second identifies the failure, and the third gives the appropriate action to be taken. Finally, the test function is used for deeper diagnosis by the maintenance personnel and is not normally used by flight crew. Selection of test causes all the lights to light up and puts an 8 in every LED, since 8 is the one number that uses every element of the 7-line display. This can be a useful function if you suspect that an LED in a number display is faulty. For instance, a 7 can appear as a 1 if one LED element has failed. On pressing the Hold button with the rotary selector in POS, the LEDs freeze and the Hold button lights up. On pressing the Hold button a second time, the light goes out and the display unfreezes to the new present position. Whilst the Hold light is on, it is only the display which is frozen. The internal calculation of present position continues. We'll now look at the yellow CDU battery light. It is essential that electrical power to the INS is not lost, even briefly, during flight. If it were, computing would stop and alignment would be lost. As we have already discussed, it is not possible to align in flight. The aircraft must be stationary on the ground. Therefore, in the event of INS power failure, all computing and navigation facilities will be lost until the end of the flight. This must not be allowed to happen, and so the INS contains its own battery, which is constantly charged from the aircraft power supplies. In the event of an aircraft mains power failure, the battery simply takes over, and power supplies to the INS are maintained. This is indicated by illumination of the CDU BAT light. The battery will last for a reasonable period of about 20 to 30 minutes, during which time the crew should attempt to reconnect aircraft main power. There will be a fault-finding checklist, which will vary from aircraft to aircraft, usually along the lines of check the circuit breakers, then check the fuses, then try resetting failed alternators, generators and inverters, and finally try switching to an alternative buzz bar. If any of these succeed in returning the aircraft main power, the CDU BAT light goes out. The situation is recovered, the battery is recharged, and no harm has been done. Otherwise, the MSU red battery light will shortly appear. There is also an MSU red battery light. As we said, the battery has only a limited charge. If the voltage drops below a specified level with time, the INS functions can no longer be preserved. In this case, the MSU battery light illuminates. This is more serious. It means that the battery is the sole source of power to the INS, and that the battery is failing. When the battery power drops below a predetermined level, alignment is lost and, in time, all INS facilities will be lost. Even if power is subsequently restored, it will not be possible to realign and all navigation computing functions remain lost. We now come on to the attitude reference function. There may be occasions when full navigation computing is not available, but the gyros are serviceable. This could be in the event of a computing malfunction so that Earth rate and transport wander corrections cannot be calculated, or it could be after an alignment failure in flight. On many aircraft, the gyros are used as primary attitude information, as well as for inertial navigation, and it may be possible to retain gyro information. This is done by selecting ATREF on the MSU, which disconnects the computing and loses alignment if this has not already happened anyway. The accelerometers now act as gravity switches, as they do during the levelling phase of alignment, and the gyros become gravity tied in the long term. They become Earth gyros. The system now gives attitude information and a limited form of heading. The gyros are normally very accurate, but there is no correction for Earth rate and transport wander, and the heading needs to be reset periodically to an independent source, which is usually a magnetic compass. In effect, the gyros are acting as a super-accurate form of DGI and as an attitude indicator. That completes the lesson on INS operation, so we'll summarise what we've covered. Selection of standby on the mode selector unit connects aircraft power to the IN. It also allows present position to be entered. Moving the MSU to a line starts the alignment process, which continues automatically for approximately 17 minutes, depending on the latitude. On completion, the MSU Ready Nav light will come on. However, it is also possible to align with the MSU selected to Nav. Once alignment is complete, we select Navigate. The alignment is now protected and the aircraft can be taxied or pushed back. If the system operates normally, it will now remain in Nav until final shutdown. Attitude reference, or ATREF, as the position is labelled, is used only in the event of a computing malfunction or loss of alignment. It maintains the operation of the gyros, but all computing and alignment is lost. It gives attitude and a limited form of heading. We then looked at the control and display unit and went through each of the rotary switch functions. The alert light gives warning of approaching waypoint changeovers. The warn light is used to indicate malfunctions. And the CDU battery light tells us that we have lost aircraft power to the IN, and that the IN's own internal battery has taken over. However, if the MSU battery light comes on, we have lost INS alignment and computing for the rest of this flight. Waypoint 0 gives us the facility to steer directly to a waypoint from present position instead of along a route. And the Hold button freezes and unfreezes the present position display. We also mentioned that the INS needs an input of true airspeed if it is to have the facility to compute wind velocity. Now that we know something about INS theory and also practical operation, we can go on to look at errors in the next lesson.